Okay, so I've set up two circuits. Over here we have the sensing circuit, which are two PN diodes connected to a 5-volt rail, and those resistors are then connected to the PN diodes, and then the anode, the cathode is then connected to the ground. Anode is connected to the resistors, and what's happening is that if you measure the potential difference between each anode and the ground, you should be approximately equal to the turn-on voltage, which is roughly around 0.7 volts for a diode. For these ones, it actually turned out to be around 0.702, something like that. I think it was a bit higher than that. But the point is that we needed to make sure that the turn-on voltage was as close as possible, so that when we measure the potential difference between each anode, it's going to be as close to zero. So the recommendation on the schematic was try to get this potential difference as close to 1 millivolt as possible. I actually managed to get it to zero on a 200 millivolt scale on the digital multimeter, which is very good. And what happens is that if you touch one of the anodes, just like this, you can see the potential difference between the two anodes will actually start to increase or decrease because of the negative temperature coefficient. So when you touch it, the turn-on voltage begins to drop, which means there's going to be more current flowing through that diode, and therefore the potential difference between this anode and the ground is going to be less than the potential difference between the other anode and the ground, and then you're going to get this difference in potential between the two anodes. Now, the point is that the difference in potential only decreases at approximately -2 millivolts per degree. So you'd actually have to get a 500-degree temperature change just to detect a 1-volt difference between the potential. And obviously that 500 volt, theoretically, even if you could achieve it, it would have to be 500 volts more or less than the temperature at the other anode over here, which would be almost impossible because remember, it's the relative difference in potential, in temperature that we're interested in. So the question is that if we only detect a very small difference in potential between a few degrees in temperature, or even a large temperature difference, how do we actually detect that? And that's where the magic of the instrumentation amplifier, the INA, comes in, because of its very, very high gain. In this configuration is 501. It means that we can take a very, very small potential difference and amplify that many, many times to a much larger potential difference. And what we've done is that we've connected the output of the INA to an output circuit, to two LEDs, which are reverse bias compared to each other. So one's in forward bias, the other's in reverse bias. What's going to happen is that when a very, very small potential difference is actually present between these two anodes, that's going to be amplified 501 times, and that potential difference is going to induce a large enough potential current that's going to be able to turn on these two LEDs. Remember, we need the potential difference to be at least equal to the turn-on voltage. So for an LED, again, you're looking at approximately 0.7 volts, maybe 710 millivolts, something like that. And because each one of these is reverse bias compared to each other, when the potential difference is positive, the current's only going to flow through one. When the potential difference is negative on these two anodes, the voltage is going to be negative, and therefore it's only going to flow through the other one. So So if you touch one, the idea is that if you touch one of the anodes, then what's going to happen is that the very small potential difference here will be amplified 501 times, hopefully enough to equal the turn-on voltage of these LEDs here. And then depending, of course, on whether or not the difference is positive or negative, either the green or the red LED will light up. So this is the first time that I've actually attempted to turn this on. Just about to plug in the positive 15 volt rail into the positive pin on the which would be pin 7 on the instrumentation amplifier, which I'm about to do. And remember, the idea is that if there really is no potential difference at all between these two anodes, no LED should light up in theory. So let's see what's going to happen. Okay, so that's interesting. That's looking, that might be promising. So if I touch one of these anodes now, let's see what happens. Nothing. Nothing. Okay, so after a little bit of playing around, I realized that I actually built the circuit correctly the first time. What was happening was that I wasn't being patient enough. We said before that if the potential difference here is enough, then the amplifier should amplify this very small difference. What we have to remember, though, and what I was making a big mistake, is that this voltage potential difference is very, very, very small. It's only 2 millivolts per degree for the change in turn-on voltage. So I've connected everything up, and I was doing this. I was touching the thing. Look, nothing happening to the LEDs over here. Again, one is reverse bias compared to the other one. And then I'm going to touch this LED over here. Again, nothing happening. But if I touch one of the anodes for long enough, watch what starts to happen to one of the LEDs. I don't know if you can see that. It's very, very faint. It's now starting to come on. It is very faint. If I maybe grab it with or pinch the anode, you can see very clearly that the green LED, oh look at that, that's amazing, is actually coming on. And that's because obviously we still need more than just a few millivolts change. It maybe needs to be maybe 5 or 6 or 7, maybe 5 or 6 millivolts. Remember, that's still 5,000th of a volt, which is very impressive to be able to detect that. And remember, that's causing a change of at least 0.7 volts for the turn-on voltage here. Now, if I let go, see, it returns back. The temperature starts to drop again. The potential, which means that the potential difference between these two anodes starts to fall to 0. And now let's try the other anode. So if I just touch it quite lightly. Well, I'm pressing on it firmly, just with one finger. Look at that. That is amazing. So you can see it's starting to come on now. If I pinch it with my thumb and my index finger, it's really starting to come on now, which is showing that the 0.7 volt turn-on voltage is now occurring. And if we know that the gain is 501, then we can actually work out backwards what the potential difference must be, simply by doing, again, if we assume that's 0.7 volts divided by 501, we're looking at 1.4 millivolts on the difference in potential. So basically what this is saying is that when this starts to come on, we've caused a change between the anodes of a potential difference of 1.4 millivolts. I'm actually convinced that it's more than that. It's probably around 2 to 3 millivolts, which indicates perhaps that some of the biasing is not correct. But again, absolutely amazing. And again, if we actually touch both of them together at the same time, remember the barrier voltage is increasing or decreasing. In fact, it's decreasing at the same rate, which means that the potential difference is going to be following each other, i.e. the zero potential is going to be following. It's going to be tracking both diodes, and that's why nothing comes on at all. Now, another thing we can do is that if we say, let's try turning on one of the anodes. So I'm just going to be holding firmly one of them, so you can see the green one starting to come on now. Remember, this would never happen if we directly connected the output to this circuit, to this terminal here, because we're only causing a couple of millivolts difference. Remember, a couple of millivolts is now causing a 700 millivolt change, which is very impressive if you think about that. Yeah, to cause 700 millivolts between these two terminals from a potential difference of only 1.4 millivolts is really impressive. Again, that's why I know that it must be more than just one, because the gain isn't 700. The gain is much closer to 500, which means it's probably about 2 millivolts, something like that. Now, if I immediately touch the other one, can you see how quickly that came off? Just like that. And if I charge the red one, so if I'm going to hold it in, and it goes nice and bright like that. And now if I immediately touch the other anode, this is going to cut off very quickly. Watch. Do you see how quickly that cut off? And the reason for that is because the potential difference is getting closer to zero much faster, because now I'm also affecting the other anode. I'm causing the other anodes, the other diodes threshold voltage to drop as well, so it can reach the zero potential a lot faster. Now, one other thing I'm going to try doing here is that I've actually got a high precision variable resistor here, which is actually controlling the gain of the INA. So what I'm going to do is I'm going to try something. I'm going to try turning on the green LED. And at the same time, what I'm going to do is I'm going to turn this, I'm going to start tuning the gain of the circuit. And what I want to try and do is increase the rate at which the green is going to turn on. So if I try just tuning that a little bit, I'm going to quickly turn it off by touching the red one. Now if I touch the red one, it's coming on like that. Okay, so that's good. I think I'm going to, if I do that a little bit more, and what I'm going to try and do is tune it while I'm actually holding or touching. See, I'm right-handed, so it's a little bit difficult. Okay, here we go. Okay, that's really good. So what I'm effectively doing now is, I think, is increasing the gain of the INA. So if I increase it quite a bit like that, can you see how bright that got now? Now, if I try touching the other one, wow. Oh, wow, that's amazing. Look at the response there. That's a much faster response. Look what happened over there. I don't know if you just saw that. It alternated to green without me even touching it. Why did that happen? So what's going on is that, oh, look, now it's going back the other way to red. This is amazing. Oh, boy, this is amazing. What's happening is that the potential difference is swinging from the positive to the negative. So what's happening is that it's going negative, and then the other anode is actually catching up, and then it's swinging back the other way. So this oscillation is, if I'm correct, this is going to involve some negative dampening, so the rate at which is this going to oscillate is actually going to slow down. But this is amazing how it's actually going like that. So if I want to just turn on, say, the red one immediately, you see the red one's just turned on like that. If I want to shut that one off and turn the green one on, I'll just rapidly decrease the threshold, the turn-on voltage for this anode. And remember, it's only when they both equalize at their room temperature threshold, which is something like 710 millivolts, that these two are actually going to turn off. But that's quite amazing that we can do that. So again, if I touch that, see, it's going to go like that. Touch that one, it's going to go like that. If I touch both of them together, that should have absolutely no effect because we're just increasing the temperature of both of them. How happens if I blow on it? Yeah, no, I don't think that's going to do anything. But that is really quite amazing. So now we've got something where we can really just touch both of them just like that, and they're going to go like that. And then remember, they're both of them now, both of the temperatures, the temperature on both of them is starting to decrease because now I'm not touching it. And as it's starting to decrease, if they're decreasing at the same rate, what might happen is that when one overtakes the other, then the other light's going to go on. So it is quite interesting to see if there's a reversal of potential. That's what a switch in the light is indicating. It's indicating a reversal of potential difference. There you go again. You see it's just swung over, which means that one has overtaken the other, and then vice versa. So that was a really nice experiment. Just to see perhaps if I perhaps increase the gain, if I can get the screwdriver in this thing even more. I think it's probably at maximum. This is a 1 kilo ohm high precision variable resistor. Yeah, so this is really quite sensitive now. And that's the important thing, is to understand why this is staying on. It will go off eventually. It just means that it's still one anode still has a different or a lower turn-on voltage, which is why the potential difference between these two anodes is going to be significant. It's going to be more than 1 millivolt. As soon as it's less than 1.4 millivolts or 2 millivolts, then such that the gain produced on the INA will be less than the turn-on voltage for the LEDs, then they'll both turn off. So that was a nice, fun experiment to do.